For this video, I combined a capacitor whose voltage goes up while it is charging with a NPN bipolar junction transistor wired as a current source. That way we can fade on an LED while it is turning on. The voltage at the base goes over to the emitter, but you lose about 0.6 volts. We'll come back to that later. But in any case, once a tiny trickle of current starts flowing, a lot more current will flow through collector to emitter, and in this case that includes the LED. It will provide whatever current through the transistor needed to maintain that voltage across the resistor. With that voltage across the resistor, it's going to set the current based on that voltage divided by the resistance in ohms, gives you the current Ohms Law. Which brings us to the capacitor. When I open the switch, the capacitor can start charging. It was holding 0.6 volts because we were discharging through a diode, which also drops about 0.6 volts. So it was holding up about 0.6 volts. But in case the capacitor started charging, you saw the LED get brighter because as the voltage went up, more current started going through base to emitter. It started seeing a higher voltage. The voltage rose across the current setting resistor, and therefore more current had to go through the LED and transistor. So hopefully that makes sense. So now you don't have to use these exact values by any means. It will just get slightly different results with slightly different values. But in case we got 47,000 ohm resistor to charge the capacitor when the switch is open. It's not draining through the diode. To transfer current over there, we don't want too much current to go, so I just used a 4,700 ohm resistor right there. So current can trickle through, but not too much. And now here you can see the voltages. The yellow line is the voltage across the capacitor being held up about 0.7 volts, almost enough to turn on the transistor there. And right below it's the voltage across the resistor, pretty much 0 volts. We're going to remove the jumper. You can see the capacitor voltage went up, and then the voltage across the resistor. So as long as the voltage goes up, more current's flowing through the LED, and it's getting brighter ultimately. So let's get rid of that diode and show what happens if we get rid of the diode. So now when it discharges, you can see there's no voltage across the capacitor. It's completely discharged. It took a little while for the LED to turn on at all. So if you like that effect better, that's all you gotta do is just get rid of that diode and connect the capacitor directly to ground to discharge it.